What are the problems of storing and transferring propellant?
Some of the key hurdles that need to be overcome besides the launch price is cryogenic fluid management technology, the ability to store propellant on orbit for a long time, the ability to transfer it in a zero-G environment from the propellant carrier, that is the thing that's delivering the propellant from the Earth to the depot, as well as the ability to transfer it from the depot to the Earth departure stage and then into the lunar descent module for use at the moon. So basically 3 things are keeping us from going forward right now. The hurdles are the low launch price that's needed for delivering the propellant to orbit, the cryogenic fluid management to keep it cold and ability to transfer it, and then the long-term customer contract. I think that the timeline is very possible to have this in place by the time the first human lunar mission occurs in NASA's timeline, which is 2018. The beauty of the approach we've taken is that we don't need to be in the critical path for the NASA architecture. Since the NASA elements are expendable, the capability to receive propellant by NASA could be incorporated at any stage in their architecture and their missions to the moon. From a technology readiness standpoint, I think the cryofluid management technology in zero-G is probably in the 4 to 5 range. We've certainly done long-term storage, long-term meaning in this case 3 to 4 days when we send out missions to GEO for delivery of satellites. We have not done 180-day cryogenic storage in space. We have done studies funded by NASA to look at what it would take to have the Centaur stage for the Atlas V, the upper stage, and the Delta IV Heavy upper stage. How long could they store propellant and what kind of loss rates they would have from an integrated thermal management standpoint, with boil-off being the cooling mechanism. The key issue is how do you transfer that propellant in a zero-G environment without a settling mode, relying on surface tension. We do that today in the shuttle with hypergolics. We do that in our satellites, but we've never done it in space with cryogenics, oxygen and hydrogen. From a technology development standpoint, I think it is just engineering, analysis, design, demonstration, and test. I don't think there's any major breakthrough that needs to happen to make this occur. We just have to put our mind to it and establish a program to go do that.